Oh, hello there, and welcome to today's presentation. My name is Professor B, and today we're going to be talking about a prince. Not your average prince, no. He was the Prince of Mathematics. His name was Johann Carl Friedrich Gauss, but he is also known by just Carl Gauss. For every story, there is a beginning, and for this one, it started on April 30th, 1777, in Brunswick, Germany. From an early age, there was something different about this young Gauss. The knowledge he had for numbers and the ability to calculate numbers before he was fully able to speak was remarkable. The year was 1782, and now Gauss is 7 years old, attending St. Catherine's Public School. Gauss was in Mr. Büttner's class when he discovered that he was no normal child when it comes to mathematics. When the students were told to solve the sum of integers from 1 to 100, as soon as the problem was given to the class, Gauss was raising his hand with the answer of 5,050. Gauss was able to solve the equation in his head by using the formula 100 times 100 plus 1 divided by 2 equals 5,050. Not only did Gauss discover the heptadecagon, he went even further with his discoveries. He discovered a mathematical formula to find all regular polygons that can be constructed using only a straight edge and compass, and he had found 31 in total. Gauss went on to write a publication in 1801, Disquisition Arithmeticae, about his number theory. The publication unifying the separate strands of the number theory. It is where modern number theory begins. With Gauss gaining so much attention with his mathematical skills, he was contacted by astronomers to help them find what they thought to be a planet by the name of Ceres. The astronomers lost sight of the new discovery, but Gauss was able to calculate the exact position of the planet. This led Gauss to determine new orbits of asteroids. In 1832, with Weber's assistance, Gauss carried out experiments whose results allowed him to define the Earth's magnetic field using units of millimeters, grams, and seconds. The very next year, 1833, the two came up with the very first telegraph system. They were also able to create the binary alphabet code, which led the two to communicate amongst each other in their separate laboratories, which was a mile and a half away. Using his divergence theorem, which he discovered independently of Joseph Louis Lagrange, he formulated two laws in 1835. Gauss's law, which relates an electric field to the distribution of electric charges that cause it, and Gauss's law for magnetism, which states that magnetic monopoles do not exist. These laws form two of the four equations needed to combine the electric and magnetic fields into a single unified electromagnetic field. But this story does come to an end. On February 23rd, 1855, Gauss would die from a heart attack at the age of 77 years old. In conclusion, throughout his life, Johann Carl Friedrich Gauss was a prodigy in the making. From his early years of being able to solve the sum of numbers from 1 to 100, or taking a compass and ruler and creating a 17-sided heptadecagon, to his dissertation on the fundamental theorem of algebra. Gauss then went into astronomy, where he made contributions for being able to calculate new asteroids in orbit. To say that Gauss is the prince of mathematics, this is an understatement. In his lifetime, he was able to make so many important discoveries that have shaped the way we go about our mathematics today. So thank you for joining me today as we talked about the Prince of Mathematics. This is Professor B. Until next time, have a good day.